Okay, if you watched that first video on circles, we talked about how, at the very end, what I said was if you have this coefficient here, but not here, then this is not a circle. I said if one of them has a coefficient, the other one doesn't, it's not a circle, right? It's an ellipse. Now when you look at this, we spent an entire day talking about how to complete the square. When this has the same format as those ellipse problems that we were looking at, right? So the directions here say write the standard form of the circle, identify its radius, and then graph it to find the domain and range. I don't think we'll go with this for right now. We'll just focus on the completing square part. You'll notice we have x squared, we have y squared. Okay. Now both x squared and y squared have a coefficient. The difference here, okay, and it's kind of a giveaway because it talks about it being a circle. The difference you'll notice is that these coefficients are exactly the same. Okay, I think I have the ellipse notes still queued up here. Let's see. Good. Okay, when we were doing this problem before, the x squared and the y squared terms here have different coefficients. Okay, here different coefficients for the two squared terms. But if you look at this circle equation, their coefficients are the same. And you'll see what happens with that once we get towards the end here. All right, so let's go quicker. We move the constant over to the other side with subtraction, right? So we're going to subtract 3, and at the same time I'm going to write my x terms together. Leave a space here. We've got our y terms together, and that's equal to -3. Now, we want to write this in the standard form for a circle. The standard form for a circle has a squared binomial for x, a squared binomial for y, no coefficients or fractions of any kind. Okay, trust the process right now, but what we need to do first and foremost is complete the square for this. So if we're going to do that, remember, we can't complete the square with the coefficient for x squared, right? No matter what's here, I've got to factor this number away from both of these. So when I factor the 3 away, it's going to be x squared plus 4x. Close that off. Again, leave the space. We're going to fill that. Take the 3 away from y squared, but I'm also taking it away from -18y. So I'm factoring 3 away from -18. That leaves me with -6, and that's equal to -3. Okay? Now we go about the process of completing the square. We take this number, +4, we divide it by 2, which is 2, and then we square that number, which is 4, and we write it here. Okay, again, this isn't a 4 because this is a 4. I take half of this and square it, and that just ends up being 4. Okay, jump over to here, same thing. Take half of -6, half of -6 is -3. Square -3, we get +9. So these numbers that are in red here, these are numbers that I added into the problem. Remember that those numbers are subject to the constants out here that I factored out. So anything that I write in these parentheses is subject to what's out here, right? So the +4 that I wrote is not really adding 4, it's actually adding 12. So I added 12 right here on the left side of this equation. So to maintain the balance of this equation, I'm going to add 12 on this side. Now I added the +9 into this quantity, but that +9 is subject to this +3. So I really added 27 as a quantity, not as the number, but as the quantity 27. So I add 27 to this side as well. Now when I write what I have, I've got 3x squared plus 4x plus 4 plus 3 y squared minus 6y plus 9. If you add all of these values together, what do we get here? What is that? 9, 36? Is that 36? I believe that is 36. Okay. Now, here's the difference. When we look at this, okay, when you look at these, well, let's go here first. When you look at these quantities, the reason we completed the square was so that we could write this as a squared binomial. Right? We want to end up here because that's the standard form that I'm looking for. Okay? So, we talked about the shortcut for this. Whatever this number was divided by 2, that's what goes here. So when I have that middle term and I split it, splitting that, taking half, right, that's +2, that goes down here. Okay, now over here, same thing. What was half of -6? Half of -6 is -3, and I can write my squared binomial like that. Now when you look at this, okay, a couple of things. There's two ways to look at this. You were told this was a circle, okay, which kind of defeats the purpose of trying to classify it. But if this is a circle, that means these numbers should not be here. So if this was an ellipse, I'd want this number to be 1, and I'd divide by 36, divide by 36, and divide by 36. Right? But I was told this is a circle. So instead of that, I'm actually going to divide the 3 away from here. And whatever I do, if I'm going to divide by 3, everything has to be divided by 3. It's great that these numbers match, because dividing by this 3 is going to cancel both of these. And I've got x plus 2 squared plus y minus 3 squared equals 12. This looks like a circle, not an ellipse, right? Because we don't have any fractions, we don't have any coefficients, it's not set equal to 1. But we have those squared binomials for x and y equal to this constant value of 12. Okay, so based on this, now we know that the center is at -2 and +3. And we know this is r squared, right? So r squared equals 12. Take the square root of both of those. We get the square root of 12, and you're in pre-calculus. You should be able to simplify that into the square root of 4 and the square root of 3. So we know that the radius simplifies into 2 radical 3. Okay, if you wanted to graph that, you could. Right? But I'm trying to emphasize here that we can still complete the square on something that looks like this to get into standard form of a circle. The difference was when we got to here. We knew it was a circle because these coefficients are exactly the same. So I divide by the coefficients here instead of dividing by this number. All right? And that's what gives us our radius value